So listen. So what was the question? Prove that the semi-vertical angle of what? Angle of a cone. What condition does the cone satisfy? So read out the question. Cone which has a given surface area. So surface area is a constant. And what is maximum?
Volume.
Maximum volume.
Volume is maximum, right? So volume is maximum
Yes,
means
sir.
we need to differentiate the volume. And what else was given? You need to prove that it was the angle.
Semi-vertical. Angle is
Sine
sine inverse of 1 by 3.
1 by 3, right? So last class, this is the method we used. So I solved it today. So listen. So this is the semi-vertical angle they are trying to speak about. I took the radius to be r, the height to be h, and the slant height to be l. So the given surface area is pi r l plus pi r square. All these things we did on the other day also. I'm just revising it again. So volume of the cone is 1 by 3 pi r square h, right? So we look at the diagram. We get r by l is equal to sine alpha. So r is equal to l sine alpha. H by l is equal to cos alpha. So we got h is equal to l cos alpha. So this also we wrote area is equal to pi into l square sine alpha plus pi l square sine square alpha. Right? I took out sine alpha on the other day. So pi l square into sine alpha into 1 plus sine alpha. So the value of l is given as the root of a divided by pi into sine alpha into 1 plus sine alpha. Right? So till here, I hope there is no doubt.
Yes, sir.
Yeah. Then what we did is, see, volume is equal to 1 by 3 pi r square. R square is L square sine square alpha into H is L cos alpha. Right? So then we get L cube into sine square alpha into cos alpha. So volume, when I substitute the value of L, it is A by pi sine alpha into 1 plus sine alpha, the whole power half raised to the power 3. So it becomes 3 by 2 into sine square alpha cos square alpha. Right? So this also we did on the other day. Then I told you, you have 3 by 2 means it will be difficult for us to differentiate it. So I told you on the other day, if volume is maximum, then volume square is also going to be maximum. Right? So when we cube on square on both the sides, what happens is this gets eliminated. So it becomes cube. So pi square by 9 into a power 3 a cube into 1 by sine cube alpha into 1 plus sine alpha the whole power 3. So here just now I observed. So I missed this pi cube, but it doesn't make a difference fortunately. So this pi cube is there. No? So pi cube into, I think the mistake that happened on the other day was I didn't square this. So it is sine power 4 alpha into cos square alpha.
No, sir. We squared it on that day.
We squared it, huh?
Yes,
But
sir. We squared, sir.
We squared it.
But today I got the answer. I don't know how. Why? Because anyways, I had to try 2-3 times. It was booked, so it was easy for me. So here one small mistake.
Sir, your voice is breaking.
No, I'm saying this pi cube is there. No, this pi cube and pi square will cancel one time. So 9 by pi will be there in the denominator. Forget about that. So what I did with this is, you get sine cube alpha into 1 plus sine alpha the whole cube, right? So sine cube alpha, this was sine power 4 alpha. So it cancels one time. Into this is cos square alpha divided by 1 plus sine cube alpha, sine alpha the whole cube. So this 1 plus sine alpha the whole cube, I wrote it as 1 plus sine alpha into 1 plus sine alpha the whole square. Okay. Similarly, cos square alpha, I wrote it as 1 minus sine square alpha. So 1 minus sine square alpha, split it as 1 minus sine alpha into 1 plus sine alpha. So one of the 1 plus sine alpha got cancelled. So what is that I'm left out with? I'm left out with 1 minus sine alpha into sine alpha divided by 1 plus sine alpha the whole square. This is the value of b dash. Okay. So once you differentiate this applying the UV rule, what happens is you will get 1 plus sine alpha common outside. Okay, you can try that. Anyways, I'll share the sheet also with you guys. So it is what you are left out with inside is 1 plus sine alpha into cos alpha minus sine 2 alpha minus sine alpha into 1 minus sine alpha into 2 cos alpha. This whole thing is equal to 0. I eliminated the denominator. So here also it is 9 by pi. Okay. So I hope it is clear till this step.
Sir, can you explain it last 2 steps, sir?
I'm saying you have to differentiate this. Once you differentiate this, applying the U by V rule, so I will differentiate and so see. 1 plus sine alpha the whole square. Denominator into derivative of numerator. What is it? Cos alpha
Cos
minus,
Cos alpha
minus sine square
2
alpha
sin
derivative
alpha
is,
cos alpha.
so that I directly wrote it as sine 2 alpha. So actually it is 2 sine alpha cos alpha.
Yes, sir. Yes, sir.
I wrote it as sine 2 alpha minus sine alpha. I took it outside. Sine alpha minus sine square alpha. That is the numerator into what is left out.
2 into
1
1
plus
plus sin
2
alpha
into
cos
1
into
plus
alpha.
1 plus sine alpha
cos
into
into cos
derivative
alpha.
into cos alpha. That's what I wrote. Then this 1 plus sine alpha I took out common. When I took out common, 1 plus sine alpha from this will be left out. That will get multiplied with this. So cos alpha minus sine 2 alpha. And here what is left out from the sine alpha into sine square alpha, I took out one sine alpha. So 1 minus sine alpha is there into 2 cos alpha is there because this 1 plus sine alpha has come out. Is that clear?
Yes, sir.
Yeah. So listen. Then once this 1 plus sine alpha comes outside, then this 1 plus sine alpha into cos alpha minus again I realize that cos alpha is common. So sine 2 alpha I wrote it back as 2 sine alpha into cos alpha. So 1 plus sine alpha which is left out multiplied with cos alpha minus 2 sine alpha cos alpha minus you have a sine alpha, 1 minus sine alpha, 1 minus sine alpha into 2 cos alpha. If you see, cos alpha is common throughout. So I cancelled it out. So when you cancel it, you are left out with 1 minus 2 sine alpha here. Okay. And here you are left out with sine alpha into 1 minus sine alpha. With the 2, with this 2 is remaining. So 1 plus sine alpha into 1 minus sine 2 alpha will give me 1 minus 2 sine alpha plus sine alpha minus 2 sine square alpha. Okay. So 2 sine alpha into 1 minus sine alpha will give me minus 2 sine alpha plus 2 sine square alpha. So 2 sine square alpha got cancelled. So 1 minus 4 sine alpha minus 2 sine alpha minus 2 sine alpha is minus 4 sine alpha plus 1 is minus 3 sine alpha is equal to 0. So I got sine alpha is equal to 1 by 3. Did you guys understand?
Yes, sir.
Yes, sir.
So this is one of the methods. I told you I'll show it in 2 methods, right? So this is one of the methods where a lot of trigonometry is involved. If at all you don't want trigonometry to be involved, you want only to go with the heights and the distances, the alternate method which I observed is A is equal to pi r L plus pi r square. So I found out L from here. L is equal to A minus pi r square divided by pi r. So volume is 1 by 3 pi r square h. So 1 by 3 pi r square into h I wrote it as root of L square minus r square. But L is nothing but A minus pi r square divided by pi r. So A minus pi r square divided by pi r the whole square minus r square. So A minus B the whole square formula. Then I took LCM. When I took LCM, pi square r power 4 got cancelled. And in the denominator you have pi square into r square. Is this step clear? This is a very important step.
Yes, sir.
So pi square r square root is going to come out like this. Pi r square divided by 3 into, I got a pi r outside. So square root of the thing that was left inside is a square minus 2a pi r square. So this is what I was left out with. So v will be equal to r by 3 into root of a square minus 2a into pi r square, where volume is a function of radius. Okay. What will be the next step? Obviously, differentiate it with respect to r and equate it to 0. So I did dv by dr and equate it to 0. Then I got a relation between area and I got the relation between area and radius. Okay. So these steps you can try it out on your own. I got area is equal to 4 pi r square. But in the first step, what is it we know? Area is, so I got area is 4 pi r square. So if I substitute 4 pi r square here, I got it as pi r L plus pi r square. Right. So 3 pi r square is equal to pi r L. R got cancelled. Pi got cancelled. So L is equal to 3r. So if you observe from this, what is sine alpha from the, what is sine alpha from this? Sine alpha is nothing but r divided by L. Right. So sine alpha is r by L means sine alpha I wrote it as r divided by L is 3r. So this and this got cancelled. So alpha is equal to sine inverse of 1 by 3. So this is another way. Same problem, you can do it in whichever method is comfortable. So as far as I observed, the second method, that is this method was easier because got the answer in less number of steps. But if at all you want to explore more with trigonometry, then you can do in this method. Whichever is comfortable for you, you people can do it. Are both the methods clear? Is there any doubt?
Clear, sir.
Clear, right? Yeah. I told you, it's slightly lengthy problem, but be careful while solving it.
Can you
So
share
can
the
you share
solution?
this?
Yeah, I'll do that.
Thank you, sir.
Yes, sir. Thank you, sir.
Okay. So we'll start with the next chapter, that is integrals. Okay. Write down the heading. As integrals of function. So generally, when you talk about integrals, there are two operations that are done. So one, we call it as indefinite integrals or So integrals is the operand, integration is the operation. Okay, indefinite integration. And the next one is definite integration. Okay, you have heard these two terms, I guess. So, can someone tell me what is integrals all about?
Summation.
Integrals is nothing but summation. So when you say summation, you already have a symbol like this one. Xi into Fi, the whole divided by sigma I is equal to 1 to n sigma Fi. You learned something like this. You already have a symbol for summation. When you have a symbol for summation, why do we need to go for some other symbol like integrals? Integrals means an elongated S. Why do we need to go for this?
Sir, maybe this is for integers, like n and I can have values as integers, but for integrals, we can do it for very small values.
Can you be more specific? It is not integers. It need not be integers alone. It can be anything else.
So the number of terms, sir.
The number of terms will be?
Number of terms will be in terms of integers in the case of that sigma that we take.
Sigma, okay.
But in case of integrals, we'll be taking it, we can take it for very small quantities.
Okay.
That's
okay. But, sorry?
For differential values, you can...
what do you mean by differential values?
Sir, very small values.
That's a very small, that's what values. Okay. You mean to say I cannot use summation for when I have 1 plus 1.1 plus 1.2, I cannot write it as summation? These are all small values only, no?
We can, sir.
You can, no? Then why do we need
0, 0, 0 on the mark.
Many negligible values like that, sir.
Okay, I can add 1.1 plus 1 plus, I can write it like this. This is a negligible value only. No, I don't know what is negligible value according to you. So how many zeros you want me to put, I'll put it.
Maybe like a slowly increasing, like how we tell it for differentiation, like a small, it's slowly reducing, like that it's slowly increasing. So you can't
Need not be
measure that.
you can integrate a decreasing function also. That's a difference.
Oh, okay. That's what I'm trying. Like it's increasing or decreasing, like that. Between those kind of small values, you can't exactly find like a definite.
See, you people are almost close, but I want a replacement for the word small.
Infinitesimal.
No, that's not. I'm not finding synonyms, man. I'm saying I want some mathematical name for it. See.
Instantaneous values.
Sorry.
Instantaneous values.
Instantaneous. Okay, it's a physics term. Okay, instantaneous. I can take it. Instantaneous values generally we don't integrate. See, I'll try to give a hint. What type of functions, because integration is also a part of calculus, the base of calculus is function. So what type of functions can be differentiated?
Continuous.
That's it. That's the answer. So instead of using infinitesimally, what you can say is, the sigma, where did you mainly learn?
Statistics.
You learned it in-
Statistics for finding mean.
So statistics is all about data. Am I right? So when you talk about a data, there are two types of data I can have in my hand. One of such data is a discrete data. Discrete data in the sense the interval between my data will be a constant. For example, you'll use not only in statistics, you can use it for arithmetic progression, you can use it for geometric progression, you can use for binomial theorem, you can use the symbol sigma anywhere, because all those topics, that is the main part of algebra, deals with data which is discrete in nature. Am I right? So you know what is the meaning of discrete. So there is a sufficient interval that is existing, that, or I can say a sufficient or a continuous interval existing between two values. So when I have that kind of a data, even if it is infinite, I don't mind. That time, whenever I have a discrete data, I'll think of summation. Whereas whenever I have a continuous data, that is what you people were trying to tell me as infinitesimally small value. Whenever I have a continuous data in my hand, I cannot integrate it. Sorry, I cannot add them up just like that, but I have to go with the concept of integration, right? So by integrating, what do you think you're going to get? For example, we learned a chapter called as applications of derivatives. First, we saw what is differentiation. We tried to understand how the tool works. See, all these are mathematical tools, okay? They're used to solve the problems in science. That's why we call them as mathematical tools. Not only science, it can be any part of business, commerce, or anything of that sort. Wherever you have something to be solved, we use these things. The question is, we learned a tool called as differentiation. Then we learned a topic called as applications of derivatives. So what was applications of derivatives mainly dealing with?
Slope of the tangent.
Yes, that's the answer. So very simple point is, derivatives are only used to find the slope of a tangent. If I have a graph in my hand, if I draw a tangent at a particular point, I can find the slope of the tangent. That's what differentiation is all about. In a similar way, what do you think integrals are applicable for?
Area under a function.
Area of the whole.
See, yes, area under a graph is right. Now again, an important question comes. When I ask about differentiation, I don't ask you how many types of differentiations are there. There is nothing like definite differentiation and indefinite differentiation, right? But here in integrals, you have two categories, indefinite and definite. So you people told me area. Which part is actually calculating the area?
Under the curve.
Under the curve, which one? Is it the indefinite integrals or the definite integrals which is going to calculate the area?
Definite integrals?
Definite. It is definite because you have a particular data in your hand. Definite means fixed data, definite, right? Whereas indefinite integration is actually not going to give you any area under a curve. It will just give you a function. Are you guys able to understand? So,
yes, sir.
First part that you will learn in your math under integrals is, the first few exercises are like how you learn differentiation for different functions. Like we saw, how do you differentiate an inverse trigonometric function? How do you differentiate a parametric function? In a similar way, we will try to understand how to do the indefinite integration for different kinds of functions. So what will be the output of an indefinite integration? It will be, can you fill that blank?
Function.
It will be some other function. But what will be the output of definite integration?
It gives area.
It gives an area. Area is nothing but it gives you a particular value. Okay, that is why when you do definite integration, you will get a number outside. The output will be some number. That number means some square units. That is nothing but the area. Okay, so first, what we are going to see is, before we get into the applications part, that is the definite integration, first we need to understand what is this indefinite integration all about. So if you ask me to put it in very simple terms, integration is the reverse process of differentiation. Okay, that is why integrals are also called as antiderivatives. So if you want me to put it in even more simpler aspect, if you differentiate a question, if you differentiate a function, okay, if you differentiate a function x power n, what do you get?
Nx power n minus 1.
Nx power n minus 1, no? So this is the question, this is the answer, okay? So if you differentiate a question, you get an answer, right? If you integrate the answer, you'll get back the question. That is what is the meaning of antiderivative. Are you guys able to understand? So what I need to do is, right? So whenever you're differentiating, right, one important aspect I always tell you is, for example, when I taught you applications of derivatives, especially the maximum minima part, the statement problems, I would have told you one important point. What is that? You have to convert a particular expression in terms of how many variables?
One
variable.
One variable, because there is actually a concept called as partial differentiation. So means if more than one variable is there also, we can solve it. But that's not a part of our syllabus. What we have learned here is only dealing with one variable. So you can differentiate only one variable is there. That is the reason I told you to convert it as one variable. So for example, if I write dy by dx, then what is the actual meaning of this other than slope? So how do you actually interpret it? So how I interpret this, I call this as derivative of a dependent quantity. So which is dependent on other? When we write y is equal to f of x, which is dependent and which is independent?
Independent is x, y is dependent.
Y is dependent and x is independent. So how do I say it? Differentiation? So differentiation is nothing but derivative of a dependent quantity with respect to independent quantity. If I tell you something like, if I give you a question, y is equal to f of x or y is equal to sin x, I ask you what is the derivative of it, my question is meaningless. What should I ask you? What is the derivative of y with respect to
x?
I need to use the term with respect to x, or else you can ask me a question with respect to what should I differentiate? Because if I try to differentiate with respect to theta, then this question is no more sin x. It is not cos x. Rather, what is the answer for this? It will be sin x into
Sin
0.
By dt.
No, it is sin x into 0. That's it.
Yes, sir.
You cannot differentiate because the function is with respect to x, but you're differentiating with respect to theta. With respect to theta, x is a constant. You're able to understand? So answer is going to be a 0. So that is why whenever you differentiate, important point is you should raise a question with respect to what should I differentiate. Okay. In a similar way, when you're doing the integration also, you need to ask a question with respect to which variable am I integrating. For example, if I tell you what is integral of sin x? See, for example, let me take the question like this. D by dx of sin x is what? This part you know.
Cos x.
Cos. So according to what theory I told you, if this is the question, if this is the answer, if I integrate the answer, I should get back the question. So how should my question be? I'm asking you, what is integral of cos x? What will you say?
Sin x.
So integral of cos x is sin x, right? But what I will say is this is wrong. Why?
Limit should be applied.
There is no limit. What should I ask? What should I ask?
Cos x dx.
Cos x.
I'm integrating cos x with respect to whom? So with respect to a variable called as dx. With respect, if I write it as integral of cos x with respect to x, then it is sin x. If I simply put a question like integral of cos x, you should not say sin x. Integral of cos x with respect to x. See, this is for the inner meaning I'm telling. But in maths, whenever we discuss, I'll generally ask you integral cos x only. It is understood that it is with respect to x. But whenever you're going for other questions, you need to look at all these minute details. That is what I'm trying to stress upon. Are you guys able to understand? So how it has actually come is, see, generally in mathematics, what does this D stand for? So when I write dx, what is the meaning of it?
Differentiation.
Differentiation of x with respect.
If it is differentiation of x, see, there are two ways you can write. I can write delta x or dx. Okay. So don't go to physics. Okay. Don't go to physics. Students who have started thinking in terms of physics, don't go to that. So delta x means what? So delta means it is a difference, right?
Difference.
So mathematically, it means difference. So difference between two physical quantities. When we discussed about approximation, we saw something like delta y. I told you delta y is approximately equal to dy. So delta x means it is a difference between two values of x. Am I right? So there are two ways in which you can see delta x. So delta x is going to be, you can write the difference in the value of x coordinate as delta x if you're able to see a sufficient distance between them. Two values which are very close to each other, then this parameter is what is called as dx. Are you guys able to understand this point?
Yes, sir.
Right. So if I take a curve like this, okay, how many such dx can I find?
Infinite.
Infinitely many, right? So depending on what limits I'm trying to set. So the value of the difference between those x coordinates will be chosen like this. See, if you have to visualize what is this integration, if I take a curve like this, if I drop a perpendicular, okay, this one and the next point are chosen so close to each other that what shape should this take?
Rectangle.
Rectangle.
Right now, yeah, it should take the shape of a rectangle. For example, if I say take the values here, it doesn't form a rectangle, it forms something like a trapezium. But I need to choose two values close to each other such that it forms a rectangle. Like this, you can find infinite rectangles between the points A and B, where the difference between these 2 points is nothing but B minus A. Okay, so when you add everything, when you add all these dx, the output will come out as x. So to put it in very simple terms, what I'm saying is the symbol stands for integration. This D stands for differentiation. What did I say integrals is? Integrals is the antiderivative.
Antiderivative.
Integrals and differentiation, differentiation or the differential coefficient are opposite of each other. They get cancelled and this output comes. Okay. So from here, if you understand this concept, what I'm trying to say is d by dx of sin x is equal to cos x. No. Now what I can do is I can take this dx to the other side. When I take dx to the other side, derivative of sin x is equal to, I'm writing it as cos x into dx. Are you guys able to understand? So if I use an operation like integral, this is the symbol. So this is called as an elongated s. So s is like this. You try to pull it up in this direction, then it becomes an elongated s. So integral and derivative, they are opposite of each other. So what will you get on the left hand side?
Sin x.
Sin x is equal to integral of cos x dx. Are you guys able to understand this?
Yes, sir.
This is what happens actually. Okay. So there is no derivation or anything. It's just you have to know the differentiation concept. You have to apply it in the reverse. Okay. So based on this, there are certain formulas that are given to us. Okay. See, derivatives. So the derivative of x power n plus 1 divided by n plus 1 is nothing but x power n. Okay, you can differentiate this and see what will you get. 1 by n plus 1 into derivative of x power n plus 1 will be n plus 1 into x power n plus 1 minus 1. That will be n. So this n plus 1 and n plus 1 will get cancelled. We will get x power n. So what will be the integral of x power n? So integral of x power n should be the function which is inside the derivative. That will be x power n plus 1 divided by n plus 1. That is x power n plus 1 divided by n plus 1. So this kind of an integration where you don't add limits. So for you to understand what these limits are, if I ask you sigma xi and sigma I is equal to 1 to 10 xi, what is the difference you are able to see?
Limits are given, no, sir?
So no limits here. So you will not know xi should be added till what value. Whereas here if I give, I'll call it as x1 plus x2 plus so on till where will you add? You will add it till
10.
So they're telling you that you need to add the first 10 numbers that you have in your hand. Right? How did I find first 10 numbers? Because the least number it starts with is 1 and the maximum number it goes is still 10. So that is why this limit is called as the lower limit. And this limit is called as the upper limit. In a similar way, if you replace the sigma with this kind of this thing, then we call it as indefinite integration. If I write it as integral of cos x dx between the limits a to b, then this is what I call it as definite integration. So definite integration means you will know the limits between which you're supposed to integrate. Then what will this be called as? So here, what is this? So there's a lower limit, there's upper limit, as simple as that. Okay. So one important point to be kept in your mind is whenever you're doing indefinite integration, you always need to add a constant to the function. I'll tell you the reason later. So I'm repeating it again. Whenever you're doing indefinite integration, you need to add a constant. Okay. So have this in your mind. So derivative of x with respect to x is 1. So what will be the integral of 1 with respect to x? So when I say integral of 1 with respect to x, 1 into dx. That is nothing but integral of dx. So what will be the integral of dx?
X.
Dx. But since you're doing indefinite integration, you need to add a c2. Okay. So in a similar way, if you look at all the formulae, the left-hand side that is given are the derivatives. The right-hand side will be the integrals of those derivatives. So observe. So derivative of sin x is cos x. So integral of cos x will be sin x. Derivative of minus cos x is sin x. So integral of sin x will be minus cos x. See, this is where the first confusion starts. Because in differentiation, what happens with respect to cos x? Derivative of cos x is minus sin x. But here, integral of sin x is minus cos x. So you have to remember this point. This is the first difference you need to make a note of. Is it clear? So similarly, derivative of tan x is
Sir, can you
secant.
repeat that? I'm sorry.
Which point?
Yeah.
See, in the differentiation part, derivative of cos x is
Minus sin x.
minus sin x. No, I've seen many of them writing integral of cos x also as minus sin x. That is wrong.
Oh.
Because you have to immediately see, once you write this, you can differentiate the right hand side and see. So when you differentiate sin x, what do I get? I get cos x. But if I have a minus here, I need to have the question as minus cos x.
Okay.
So it should be plus. So integral of sin is minus cos, derivative of cos is minus.
Okay.
So that is what the point I'm trying to stress on. So similarly, derivative of tan x is secant square x. So what will be the integral of secant square x? It will be tan x. Right? It will be tan x. Similarly, derivative of minus cot x. So we'll do one thing. I will write everything you people tell me without looking at the book. So especially the trigonometric parts. So derivative of sin x with respect to x is cos x. So derivatives integral. So integral of cos x dx will be equal to, you also write it down. So integral of cos x sin dx will be sin x
plus c.
Okay. Similarly, d by dx of.
Sir?
Yeah, tell me.
Sir, in every integrals we have to put plus c, sir.
Indefinite integrals, yes.
Yeah, okay, sir.
Definite integrals you need not put. That also I'll tell you why. Okay. But it will take some time. So first, let's look at the formula. So d by dx of minus cos x is sin x. So derivative integral of sin x will be
minus cos x.
Minus cos x.
So d by dx of tan x is secant square x. So what will be integral of secant square x?
Tan x
plus c.
Sir, why do we take that as d by dx of minus cos x? Why can't we just take cos
You
x?
can take it. You can take it. Then integral of question should be integral of minus sin x.
Oh, okay.
Okay. Next. So what do you think will be the integral of tan x dx?
Secant x tan x plus c.
Sorry?
Secant x tan x plus c.
No. What you're saying is what? Derivative of which function is tan x? You try to revisit everything. Integral of secant square x is tan x. I'm asking derivative of which function is tan x. If you look at all the sheet that you have, nothing, you don't have anything. Okay, there's one more confusion that will start. So don't make this mistake. So the next one. So first, let's write down the derivatives of all the trigonometric functions. So similarly, derivative of secant x, what will it be?
Secant x tan x.
So then the integral of secant x tan x should be what?
Secant x.
Secant x plus c.
Secant x plus c.
Similarly, d by dx of cosecant x is what?
Minus cot
square. So if I need to get plus cot square x for me to become a question, I should put a minus here. So derivative of minus cosecant x is nothing but
cot square.
So integral of cot square x dx will be equal to
minus cosecant x.
Minus.
Okay. Next. D by dx of cosecant is also sin cos. Okay, cot. So integral of cot is minus cosecant cot. So what should I make the question as? Derivative
Minus cos.
Minus cot x.
Minus cot x.
is cosecant x cot x.
Cosecant
Right?
x cot x.
So it will be integral of cosecant x cot x with respect to x will be equal to minus cot x plus. Okay, these are all the very basic formula that you're supposed to know. Just a minute. I hope you people are writing. See, there'll be a lot of confusion, guys. You will feel as if you have understood, but while applying, I've seen many of them are doing mistakes. So I suggest you to write it. So that's why even I'm writing it, okay?
Sir,
So, tell me.
The differentiation of minus
cosecant x is
cosecant x is cosecant x cot x, sir, not
minus
cot square x.
cosecant x cot x, not cot square x.
Oh, sorry. No, see. Oh, I wrote it reverse, sir.
No, sir, differentiation of minus cosecant x is equal to cosecant cot x.
Wait. I swapped it. I'm sorry. So see, secant x is secant x tan x. So this will be cosecant x cot x.
Cot x.
Sorry about it. Yeah, I'm sorry.
Yes, sir.
I wrote it. So it will be integral of cosecant x cot x will be
Cosecant x cot x.
minus cosecant
Minus
x.
cosecant x plus c.
So integral of cot x will be minus cosecant square x. So cosecant square x will come here. So integral of cosecant square x dx will be equal to minus cot x plus c. Right. Next. The next things we are going to see is inverse trigonometric function. So derivative of sine inverse x. 1 by
Root
Over
of
1
1 minus x square.
root of 1 minus x square. So the integral of 1 by root of 1 minus x square dx will be obviously
Sine inverse x plus.
Okay, so it will be a sine inverse x plus c. Similarly, derivative of cos inverse x is what? Cos inverse x.
Minus 1 by root of 1
by
minus
root
x.
of 1 minus x square.
So I can write it as derivative of minus cos
Minus
inverse
cos inverse x.
So here, what is the trick you are able to observe? So derivative of sine inverse x is also 1 by root of 1 minus x square. Derivative of minus cosecant inverse x is also 1 by root of 1 minus x square. So for integral of root of 1 by 1 root of 1 minus x square, I'm repeating it. Integral of root of 1 by root of 1 minus x square. Should I take sine inverse x or minus cos inverse x? Which one is right?
Depending on the interval.
Depending on the
Interval.
here, no interval. Forget about interval as of now. You assume that you don't know anything like interval existing. So which one should I take? The answer is both are right. Okay, but most of the time we take sine inverse x only. This kind of a scenario occurs with respect to inverse trigonometric function. Why I told both are right is because integral of root of 1 by root of 1 minus x square with respect to x is, according to this statement, what will it be?
Minus cos inverse x.
Minus cos inverse of x plus c, right?
Yeah.
Okay, one thing that should be there in your mind is plus c is not a fixed value. Okay, c is just a symbol that we are using. It is some constant, I don't know, it can be plus 1, minus 1, half, 0, anything. I don't know what it is. But one relation that I know is the property between sine inverse x and cos inverse x. What is this?
Pi by 2.
Pi by 2 is there, no? So, sine inverse x, I can write it as pi by 2 minus cos inverse x. Can I write it like this? Right.
Yes.
So, what did I first write the integral of 1 by root of 1 minus x square as? The first one I wrote is
X plus.
sine inverse x plus c, right? But can I replace sine inverse x plus by pi by 2 minus cos inverse of x? Can I do that?
Yes, sir.
Yes, sir.
So this pi by 2 plus c will become some other constant. I can write it as k. Are they both not the same? Are you guys able to understand this small point?
Yes, sir.
There's a very, very minute point which is generally missed.
Sir, so should we use different constants?
It's not about different you can write any answer. I'm saying both are right. why I'm telling this is when you solve the problem, some of the books will give you the answer as C. This might not affect you here as a formula. Try to understand. But what happens is when you refer some of the books, if suppose you're solving a problem from some book, one of the books will give you the answer as sine inverse. One will give you as minus cos inverse. That moment you will start getting confused. So what I'm trying to say is whether it is sine inverse x or minus cos inverse of x, that is going to be the integral of 1 by root of 1 minus x squared dx. But only thing is constants will vary. You need not worry about the constant unless the question imposes a condition on it. So there are certain questions which will impose a condition for you to find the constant that you will understand when I solve the exercise. So as of now, have this point in your mind. So integral of 1 by 1 root of 1 minus x squared dx, you can either write it as sine inverse x plus c or minus cos inverse x plus c, both are right. As long as that c is something else, we don't know what that c is. Okay, you should have that c as some constant in mind, not as a number. That is a point. In a similar way, what will happen to the other inverse trigonometric function? 1 by 1 plus x, derivative of tan inverse x.
1 by 1 plus x.
1 by 1 plus x square. Derivative of minus cot inverse x. 1 by 1 plus x.
1 by 1 plus x square.
So integral of 1 by 1 plus x square dx, what should I write it as?
Tan inverse x.
Tan inverse of
Inverse
x
x
or
plus
cot
k.
inverse minus cot
Minus
inverse
cot
of
inverse
Minus
x
x
plus
cot
plus
inverse of x plus
I'm
k.
writing, I'm using, for your understanding, I'm using some other constant k. Okay. So have this in your mind. So or else you can write the C1 and C2 also. It's up to you. Similarly, what will be the next parameter you need to take care of? D by dx of
mod x
So,
secant it.
1 by x into root of x square minus 1.
Sir, integral, sir.
Derivative, no?
You have put integral, sir.
Where did I put integral?
sir, in the page
Oh, sorry,
you are
sorry.
writing.
D by dx of secant inverse x is 1 by x into root of x square minus 1. Okay. And this is also the derivative of minus cosecant inverse x also. This will also 1 by x into root of x square minus 1. So what will be the answer? 1 by x into root of x square minus 1. Its integral will be secant inverse x plus c or minus cosecant inverse x plus some constant k. So they both are right. Okay. So these are all the formulae that you're supposed to know. Next, the basic ones are you people copying this or done? You want to copy this?
We copied.
Yes, sir. 2 minutes, sir.
Yeah.
Yeah, over, sir.
Done? Okay. So the next basic functions are derivative of e power x is e power x. So integral of e power x is also e power x plus c. So similarly, derivative of log x is log x base e is equal to 1 by x. So integral of 1 by x will be log x.
Log x.
So derivative of, do you people remember the derivative of a power x? That is a power x.
A power x log a.
Log a, right? So the derivative of a power x by log a will be a power x. Can I write it like this? Because log a is a constant, I can bring it to the other side. So what will be the integral of a power x dx? It will be a power x, right? So to put it in very simple terms, how you are supposed to start practicing is, whenever you see integral, you should think like this. On differentiating which function will I get this value? So that should be the answer on your right hand side. Okay. Next. Now I'll explain why we need to add a constant. Okay. So you will understand it. That's what is given as geometrical interpretation of indefinite depth. Now, see the example they have considered is y is equal to x square. Okay. So if I give you y is equal to x square, if I ask you what is going to be the shape of the graph for this?
Parabola.
What shape?
Parabola.
Parabola.
It's what parabola?
Upward.
It's an upward parabola. So I put y is equal to x square plus 1. What parabola is this?
Upward parabola.
Upward parabola.
It is still
By 1 unit.
1.
So it will get shifted by 1 unit in the upward direction.
Upward direction.
So y is equal to x square plus 2, shifted by 2 units.
2 units.
If you observe all the graphs, are they not going to look like this? X square plus 1, x square plus 2, x square plus 3, so on. So x square minus 1, x square minus 2, x cube minus 3, everything. So what I'm trying to say is, if you draw a line x is equal to a, what does x is equal to a represent? It is a line which is parallel to y-axis. So this x is equal to a is going to cut the curve at one point, because all these are getting cut at one point. Am I right? So when this is happening, at the point where this x is equal to a is cutting the curve, at that point will you be able to draw a tangent? Right? So you'll be able to draw a tangent. So you're able to see these dotted lines. I'll reduce the marker size up. So are you able to see these dotted lines?
Yes, sir.
Yes, sir.
Right. So these dotted lines represent the tangent to those curves at the point x is equal to a. Am I right? So they are the tangents to each individual curve at x is equal to a. So what is the slope of a tangent according to our previous knowledge? If you differentiate the curve and substitute the value of x is equal to a, so that is going to be the tangent. For all these curves, if I differentiate, and what will I get?
Constant.
I'll only get 2x. No? So if the slope of all the tangents are equal, they're parallel to each other, right? So, one minute. Now try to understand. So dy by dx, if I take the curves like this, for this dy by dx is 2x. Okay. Now if I do the reverse process means integration. So dy is equal to 2x dx. If I integrate on both the sides, what should I get? Y will be equal to, see, just like how 2 you can take out, how will you integrate
X square by 2, sir.
Yeah, integral of x power n dx.
1 plus 1 by.
Yeah, for those who don't know the formula, observe it. The first formula, integral of x power n dx is x power n plus 1 divided by n plus 1. Right. So 2 into, if I write x square and leave it, 2 into x square by 2, if I leave it like this, okay. So where did I get this 2x from? From the first one. When I got it from the first one, I differentiated and again integrated it back. What am I getting? I am getting x square. Okay, it is matching. From the second one, what do I get? Is equal to 2x. Right? So from the second curve, y is equal to x square plus 1. If I differentiate this, what do I get? 2x. So dy will be equal to 2x into dx. Again integrating on both the sides. Y will be equal to x square. Right? So when you differentiated it, you got it as 2x. When you differentiated this also, you got it as 2x. When you integrated back, you got this as x square. This is also coming out as x square. But where did you get this 2x from in this question? You didn't get, you got it from x square plus 1. You actually didn't get it from x square. So what mistake is happening if we ignore the constant? So here, why the constant is added is because you can get set of parallel slopes like that. For any number of curves, depending on the constant, the curve will get shifted either in the upward direction or downward direction. So that when you try to draw a tangent to that curve at a particular point, all those set of tangents will be parallel to each other. That is the reason why you need to add a constant. Okay. You need to add a constant only for which case? Only for indefinite integrals. Definite integrals, what will happen is it will get cancelled. That time you will understand. By that time, you will definitely be able to understand it better. So as of now, on a basic level, are you people able to understand why this constant is added?
Yes, sir.
Yes, sir.
Yeah, that is what this constant is. Here the constant is 0. I can add x square minus 1. So that is going to shift the curve either in the upward direction or downward direction with respect to x-axis. So curve will be going up or down. Okay. Next is, you write down this one. Some properties of indefinite integrals. So what are some properties that we are going to see? So integral of f of x dx there. If you differentiate the integral, if you differentiate the integral, what do you get? You get the function which is being integrated. So you get the function inside the integral. Are you able to understand this point?
Yes, sir.
Similarly, integral of derivative will be equal to the function itself. Because if I differentiate f of x, I get f dash of x. Okay. But since I'm doing indefinite integration, I'll add a constant. As I told you, there are no proofs for this. It is only the reverse operation that we are doing. So concentrate. Okay. Next. So look at the second property. Two indefinite integrals with the same derivative lead to the same family of the curves, so they are equivalent. So what do you mean by that? Two indefinite integrals with the same derivative. Can you give me an example we just now saw?
Because
so they belong to the same family, they are saying, so they are equivalent. Okay, it is better you understand in the graphical method. Next. The next property is when you do integral of f of x and g of x separately, sorry, if you have sum of two functions f of x plus g of x, f of x plus g of x dx, then it can be integral of f of x dx separately plus integral of g of x dx separately. So it can be plus or minus also, to be more specific. Okay. The best example we can take is integral of x plus sine x into dx. So what will the answer be? It will be integral of x dx plus integral of sine x dx. So what is the integral of x?
1.
X square by 2.
X squared by 2.
Oh, x square by 2.
X square by 2 minus plus
Cos x.
Plus, so I will write minus cos x. You will add some constant.
Plus c.
Plus c. That's it. Okay. Similarly, if you have any real number in your hand, if that real number is multiplied with a function, okay, let's say you have a question like integral of 2 sin x dx. Then what you can do is you can take 2 out of the integral. So this has been the common property for every operand. Right. So you'll take 2 outside, 2 into integral of sin x dx will be 2 into minus cos x plus c. So that's what this property says. Okay. So this is a combination of third and fourth property. Okay. Now, if you look at the first exercise, the first part that they do is they will not do direct integration. They will not do direct integration. They will use a method called as inspection. Okay, they'll use a method called as inspection to solve. So observe this. So write the antiderivative for each of the following functions using the method of inspection. Means they're asking what is integral of cos 2x with respect to x. Now, when I say method of inspection, what are you supposed to think? Derivative of which function is cos?
Sine.
Sine. So we know that derivative of sine is cos. But what is the angle here?
2x.
So I should write it as sine 2x. So derivative of sine 2x is going to give me, what is it going to give me?
2 cos 2x.
2 cos 2x.
2 cos 2x. Then what should I do? I should take the dx to the other side. So derivative of sine 2x is equal to 2 cos 2x into dx. Is this step clear? Now integrating on both the sides, what you can do is, tell me.
Take 2 outside.
So d and this integral are counter operations of each other. So integral of sine 2x is equal to 2 times. The question is integral of cos 2x dx. This is what the question is, no? Integral of.
Sir.
So this 2 will come this side. So it will be sine 2x divided by 2. So here we don't add any constant because we did it using the method of inspection. So the question can either be sine 2x plus 2 also, anything. So the answer is sine 2x by 2. Are you guys able to understand this point?
Yes, sir.
Yeah. Sure. Now can you people try the next one? Using the method of inspection, you need to find what is the integral of 3x square plus 4x cube. So derivative of which function will give you a square?
Cubic.
Cubic function. So derivative of x cube So you should write like this. D by dx of, so if I need an x square, I need to write an x cube. I don't know what is the coefficient. I'm not worried about it. If I need a third degree equation, I need to differentiate a fourth degree. So x cube plus x power 4. First differentiate that and see. So I'll write it separately so that you're not confused. So listen. So what is the question? Integral of 3x square plus 4x cube.
Yes, sir.
Okay. So integral of 3x square plus 4x cube is going to be what? So d by dx of x cube plus x power 4 is going to be 3x square plus 4x cube. Now what should I do? Take dx to the other side. So derivative of x cube plus x power 4 is equal to 3x square plus 4x cube with respect to x. So integrating on both the sides. Now I get x cube plus x power 4 is equal to the question. So the answer is x cube plus x power 4. So since now you know the formula also, can you verify whether this is right or wrong? We'll do the direct integration. So if I need to do the direct integration, this is f of x, this is g of x. So integral of 3x square dx plus integral of 4x cube dx. Can I write it like this?
Yes, sir.
Yes, sir.
Right. So integral of 3x square dx plus integral of 4x cube dx. So 3 will come out, integral of x square dx plus 4 will come out, integral of x cube dx. What will I get? So 3 into integral of x square is x power n
X cube by 3.
plus 4 into
X power 4 by 4.
it's the same thing, no?
Yes, sir.
Yeah. Both the ways will give you the same answer. You can use it for verification. See, generally these questions are not asked, but since it is given here, I'm explaining. Okay. Similarly, antiderivative of 1 by x. So derivative of which
Sir,
function?
can you show that page, sir? I will take screenshot.
Yes.
Thank you, sir.
Yeah. So now listen. Antiderivative of 1 by x. So derivative of which function is 1 by x?
Log x.
Log.
So log x is the answer. Log of mod x. Okay. The next is find the following integrals. So from here onward, we are going to use the formula. That is integral of x cube divided by x square. So whenever you have this kind of an expression, okay, you first need to verify the powers of the numerator and denominator. If the power of the numerator is greater than the denominator in terms of algebraic variables, you split and write the terms. So it is going to be integral of x cube by x square minus integral of 1 by x square with respect to x. So this will go one time. So integral of x dx.
X square by 2.
Minus integral of this, I can write it as x power minus 2 dx. See, one important point I want you all to make a note of is when you do integral of x power n dx, n can be positive or negative. It can be a fraction, but the only value that it can't take is minus 1. Because if it is minus 1, it will become x power minus 1 dx. X power minus 1 is nothing but 1 by x dx. Integral of 1 by x is nothing but
Log of mod x plus
log of. So this is the only case you need to keep in your mind. Except that it can take plus minus fractional value, anything of that sort. So keeping all these points in mind, this I can write as x power minus 2. So now n value is minus 2. X power n plus 1 divided by n plus 1. So x square by 2 minus of x power n plus 1 divided by n plus 1 plus c. So x square by 2 plus 1 divided by x plus c. If you want, you can check derivative of 1 by x is minus 1 by x square. That's what is given in the question. Right. So can you do the next one? X power 3 by 2. So x power 3 by 2 plus 1 divided by 3 by 2 plus 1.
So 3x 5 by 3 by 5 plus x plus c.
Let me check. So integral of x power 3 by 2. I'm directly writing it. So x power 3 by 2 plus 1 divided by 3 by 2 plus 1 plus 2 into e power x minus log of mod x. So how much is this value? 5 by 2. So x power 5 by 2, here you will get 2 by 5 plus 2 e power x minus log of mod x. Don't forget this. Got it? Now next one is find the following integrals. Integral of sin x plus cos x dx. How to do this? So integral of sin x plus cos x dx. So I can write as integral of sin x dx plus integral of cos x dx. So integral of sin
Minus
minus cos x plus
Minus
integral
cos x sin x.
So that's the answer. Okay. Integral of cosecant x into cosecant x plus cot x.
Sir, அங்க ரெண்டு c வந்தாலும் ஒரே c எழுதலாமா?
Yes, it is. Can I see? Integral of sin x dx will
Integral
be
of minus cos x is only sin x, no, sir.
Integral of sin x will be minus cos x. Then.
No, sir, the integral of minus cos x only will be sin x, no, sir.
Both are same only. See, integral of minus sin x dx is cos x means this minus will go to the other side. No question will have a minus sign.
Okay.
Okay, always the answer will have the minus sign. So minus cos x plus c1 plus sin x plus c2. The c1 plus c2 I'm calling it as c.
You don't need to specify, sir. 2c.
You need not. That's what I'm saying. Constant can be anything. You need not concentrate on the c at all. You can just take it as two different variables. That's okay. Next. So integral of cosecant x plus cosecant cos x. So integral of cosecant square x dx plus integral of cosecant x cot x dx. So derivative of which function is cosecant square?
Minus
cot x.
Cot x.
It is minus cot x plus derivative of which function is cosecant x cot x?
minus cosecant
Minus
x.
Minus cosecant x plus c. That's the answer. Minus cot x minus cosecant x plus c. Okay. So 1 minus sin x by cos square x. 1 minus sin x divided by cos square x.
Sir, the 1 by 1 plus sin x.
Can we separate it, sir?
You can separate it. Secant square x dx minus integral of sin x by cos x is, see, sin x by cos square x means I can write it as sin x by cos x into 1 by cos x. So sin x by cos x will be tan x into secant x. So integral of secant square x is
Tan x.
So derivative
Tan x.
Minus derivative of which function is secant x tan x? It is secant x.
Secant x.
Yes, that's the answer. Okay. So the fourth one is a problem where you will have to find out the constant based on the condition they are given. Okay. So find the antiderivative f. So capital F is a function which you get as an answer by integrating the small f of x. And they have given you capital F of 0 is equal to 3. So whenever they give you that value, indirectly that question means you need to find what is the constant and then write it down. Okay. So what is the integral of f of x dx? See, don't look at the solution. Integral of f of x dx. What is it? Integral of 4x cube minus 6. So 4 into
minus 6
minus 6 into integral of dx. So 4 into x power 4 by 4 minus 6x plus some constant, right? So 4 and 4 will get cancelled. It will be x power 4 minus 6x plus some constant. This is what is capital F of x, right? So what is capital F of 0 given as? 3. So when you substitute, so capital F of 0 means wherever x is there, I'll substitute a 0. So I'll get C. So capital F of 0 is nothing but 3. So what will be capital F of x as? X power 4 minus 6x.
Minus 6x plus 3.
So this is called as a particular solution. Okay, you got some solution which is very particular. The other things you are writing C, that is the generic value. That type of a solution is called as general solution.
Sir, how C is 3, sir?
Because I got f of x. This you understood, f of x is equal to x
Yes,
power.
sir.
What have they given? F of 0 as capital F of 0 is given as 3.
3.
So I substitute 0 in the place of x. What do I get?
Okay, 3.
3. So C will come out as 3. So capital F of x is, you take the C and substitute it back here. Got it? So I'm not confusing with all these points. You can see that while we do the exercise. Can you tell me what is the answer for antiderivative of sin x using the method of inspection? So whenever they say method of inspection, you need to think derivative. Derivative of which function is going to give me sin?
Cos
2x.
So you should start as, we know that derivative of
minus cos.
Derivative of cos, just write it as cos 2x. Derivative of cos 2x is equal to minus sin 2x. Okay, or okay, you are comfortable like that, we can go with that also. Both are same. Derivative of minus cos 2x is sin 2x. Is that all?
2 sin 2x.
It is 2 sin 2x. So derivative of minus cos 2x will be equal to 2 sin 2x into dx. So integrating on both the sides, what will I get the answer as? Minus cos 2x is equal to 2 times integral of sin 2x dx. This is the question. So 2 will come to the left hand side. So answer will be minus cos 2x divided by 2. Okay. So I'll just tell you one point. Anyways, you learn it in the next exercise. Integral of sin x is what?
Minus cos x.
Minus cos. So integral of sin 2x dx will be minus cos of the same thing 2x. In the case of differentiation, what you will do is you will do the chain rule. So that is why you will get 2 into something. No? Whereas in the case of integration, you need to divide it with this. So divide it with this value. If I follow the same pattern, what will be the integral of secant square of 5x?
Secant x tan x.
Derivative of which function is secant square?
5 tan x.
Tan
X.
5 tan x.
Tan 5x.
Tan 5x by 5.
Tan 5x divided by 5. Okay, so how you are supposed to see is integral of which function, derivative of which function is secant square. Derivative of tan is secant square. Tan of how much value? 5x. 5x. Since x is multiplied with a 5, in the case of integration, divided with 5. Is it clear? So similarly, integral of cos 2x dx. Derivative of which function is cos?
Sin 2x.
Sin 2x
by 2.
That's it. Okay, anyways, you will learn this in the next exercise, nothing new. I'm just telling you this so that you will verify it. Similarly, what do you think will be the answer for cos 3x?
Sin 3x by 3.
Sin 3x by 3.
That's it. Sin 3x by 3. So with the hope you people know how to solve it, I'm not doing it. Integral of e power 2x.
E power 2x. E power 2x.
It is e power 2x divided by 2. Wherever x is getting, see, integral of e power x is e power x. If it is integral of e power 2x, x is getting multiplied with the 2, no, that should be divided again. Because you differentiate the sense, you know. Okay, let's make it simple. They're asking integral of e power 2x. So integral of which function is e itself? That is e only. E power 2x.
2x.
Right. Sorry. We are doing using the method of inspection. So d by dx of e power 2x is going to be e power 2x. So what e power 2x?
E power 2x into
2. So dx will go to the other side. So derivative of e power 2x is equal to 2 into e power 2x dx. So integrating on both the sides, e power 2x will be equal to 2 times integral of e power 2x dx. This is the question. 2 will come to the left hand side, become as by. Okay?
Okay, sure.
Yeah. So what I'm trying to say is, If integral of f of x is capital F of x, then integral of f of ax will be equal to capital F of ax divided by a. Okay, you can make a note of it. Okay. So the next part you can directly integrate it. So this part you can directly integrate from the sixth question onwards. So 4 and 5 you people try. If you have any doubt, I'll clear it in the next class. So we need some time to absorb it. No? So integral of 4 into e power 3x plus 1. Find the integrals of the following. Tell me.
Sir, is it 4 e power 3x by 3 plus e?
Plus?
4 into
Plus x
e
plus
power
c.
3.
Sir, what is
You forgot
integral of
something
a
in between.
constant, sir?
Plus x plus c.
Yes, you forgot x. See, 4 into
Yeah,
integral of
forgot, sir.
e power 3x is e power 3x by 3 plus integral of 1
Plus,
into dx is x plus c. Is there anyone having a doubt with this? Is there anyone having doubt? Guys,
no,
let
sir.
me see.
Can you explain it again, sir?
For infinitely small values. Yeah, sure. So what I'm trying to say is integral of 4 into e power 3x plus 1 into dx is there. No? So this is f of x, this is g of x, right? So integral of 4 into e power 3x dx plus integral of 1 into dx. Is this clear? So 4 is a constant. So 4 will come out. 4 into e power 3x dx plus 1 is a constant. So integral of dx. So this will be 4 into, what is the integral of e power 3x?
E power 3x by 3.
So that's what I wrote. So e power 3x by 3 plus integral of dx is x.
Yes.
And you need to add a constant because it is indefinite integration. Okay. Now, integral of x square into 1 minus 1 by x square dx. Integral of x square into 1 minus 1 by x square dx. So what you do is multiply the x square inside.
X cube by 3 minus x plus c.
X cube by 3 minus x plus c. Yes. So if there is anyone who didn't understand, please let me know. I'll explain it.
Sir, can you explain the seventh question once?
Seventh, sure. So seventh is integral of x square into 1 minus 1 by x square dx. So here it is like u into v. You don't have any formula as of now, u into v. As of now, you don't know, right? So what you need to do is you have to make it as a simple function. So multiply this x square inside. X square into 1 is x square minus x square into 1 by x square is 1. So x square minus 1 dx. So this thing is same as x square minus 1 dx. So it is integral of x square dx minus integral of dx. So what is integral of x square? X power n plus 1 divided by n plus 1, the very first formula. Minus integral of dx is x plus a constant. Is it clear?
Yes, sir.
Yeah. So can you guys try the next one? So what is the answer for the next one?
A into x power
Ax
3
cube by
by
3
3
plus
plus b
bx
into x
square
cube
by
by
2
Yeah.
Plus cx. Plus c.
plus cx plus a.
Plus some constant. Because you have already used c here, you use some other. Plus some constant k. Okay. So I'll tell you what all problems you can actually do as homework. This one you can do it. All these are simple, okay? So for the 10th one, what you need to do is expand and then do it. A minus b the whole square and then do it. Certain terms will get cancelled. 11th one, what is the idea? Numerator is greater than the denominator. So split
We can
the
divide by x square.
divide by x square throughout. Similarly, 12th one also same logic. Okay. Now I'll do the 13th one. So 13th one is x cube minus x square plus x minus 1 divided by x minus 1. So what is it? X cube minus x square, it is the 13th question, plus x minus 1 now. Is that the question?
Yes, sir.
Yeah. So what you can do here is, so this is an algebraic expression. So here if I observe between x cube and x square, what is common?
X square.
X square.
I can take out x square outside, x square into x minus 1 plus 1 into x minus 1. Can I write it like this? The whole divided by x minus 1. I need to find the integral of this. So that's what the question is, integral with respect to x. So integral of, it is like factorizing two terms. I can take x minus 1 outside into x square plus 1 divided by x minus 1 into dx. So x minus 1 will get cancelled. So the answer will be
x cube by 3.
Yeah.
X cube by 3 plus
x plus c.
Plus c.
Cube by 3 plus x plus c. So is there anyone who is not clear with what I did?
Sir, I want 8th question, sir.
8th.
Yeah.
8th is nothing. You have to take out the c. Integral of ax square dx plus integral of bx dx plus integral of c dx. So take out a outside. So a into integral of x square dx plus b into integral of x dx plus c into integral of dx. So what is integral of x square?
Okay, x cube by 3.
No, that's the method. That's it.
Okay, sir.
Yeah. So 13th, I hope it is clear. If anybody is copying, copy. If there is any doubt, let me know. So there is no doubt. Okay, we'll proceed to the next one. 14th one is integral of 1 minus x into root x. So integral of 1 minus x into root x dx. So this will be the, so this will be root x minus integral of x into x power half is x power 3 by 2 dx. So integral of x power half dx is how much? X power n plus 1. So n is half plus 1 divided by half plus 1 minus integral of x power 3 by 2. X power 3 by 2 plus 1, the whole divided by 3 by 2 plus 1. So plus c. So this will be x power 3 by 2 divided by 3 by 2 minus x power 5 by 2 divided by 5 by 2 plus c. So this will be 2 by 3 times x power 3 by 2 minus 5 by 2 times x power 5 by 2 plus c. Anyone with a doubt?
Sir, it's 2 by 5, sir.
2 by 5.
2 by 5, sir.
2 by 5, yeah. 2 by 5. See, whenever, generally when you're integrating a fractional part with the power, then you will get it as a fraction which is less than 1. So 2 by 5 is less than 1, 2 by 3 is less than 1. You will get something like that. Is everyone clear?
Yes, sir.
Yeah. So 15th one, same logic. Multiply x with whole thing. 16th one, split each term and do it. Okay. 17th one, again split and do it. So 18th one, split and do it. So secant x into secant x. Integral of secant square x dx plus integral of secant x into tan x is secant x into tan x dx. So what is integral of secant square x?
Tan x.
Tan x.
Plus integral of secant x tan x is?
Secant x.
Plus 3.
That's the answer. Okay. So we'll do 2 last problems and then wind up. So the question is, see, 19th one is integral of secant square x divided by cosecant square x dx. So we don't have any form of this sort. So wherever you see secant square like this in combination with cosecant square, convert them in terms of sine and cos. Okay. When I convert them in terms of sine and cos, I get it as 1 by cos square x divided by 1 by sine square x. Right? So everybody concentrate here. So integral of what will happen is sine square will go to the numerator. Integral of sine square x divided by cos square x dx. So that is integral of tan square x dx. So in derivative of which function is tan square?
Nothing.
Nothing, right? So tan square, what I will do is I will write it as secant square x minus 1. There is an identity. Secant square x minus tan square x is 1. So what I did is I wrote tan square x as secant square x minus 1. Okay. So this will be, yeah, tell me. Yeah. So it will be integral of secant square x dx minus dx. So derivative of which function is secant square?
Tan x.
Tan x.
Tan x.
Minus x plus.
Minus x.
So this is an important problem. So whenever you see tan square x, this is a universal method to solve an integral. Wherever tan square x comes, you have to convert it as secant square x minus 1 and then proceed. Okay. So 20th one, we can do it in the next class. So I'll stop the session with this. Just wait for 2 minutes. I'll take the screenshots and you can do it.